Welcome in today's lecture. In this lecture, we will talk about the nature of the roots of a quadratic equation. A quadratic equation is any equation that can be rearranged in standard form like this, where x represents an unknown, and a, b, and c represent known numbers, where a is not equal to 0. If a equals 0, then the equation is linear. The values of x that satisfy the equation are called solutions of the equation, and roots, or zeros of the expression on its left-hand side. A quadratic equation may be solved using different methods. But, with the help of quadratic formula, we can solve any and every quadratic equation. Every quadratic equation must have two roots. Let they are x1 and x2. These x1 and x2 are because of the plus, minus sign in the quadratic formula. Therefore, writing them separately, we get two roots. Therefore, the solution set of the quadratic equation contained x1 and x2. We will talk about the nature of the roots of the quadratic equation. But first, let us know and understand that what is discriminant of the quadratic equation. That part of the quadratic formula, which is inside the square root, is the discriminant of the quadratic equation. Nature of the roots of the quadratic equation depends upon this discriminant. Let us see that how roots depend on the discriminant of quadratic equation. When the discriminant is greater than 0, the roots will be real and distinct. If the discriminant is greater than 0 and perfect square, roots will be rational. If the discriminant is greater than 0 but not a perfect square, roots will be irrational. If the discriminant is equal to 0, roots will be real and equal. If the discriminant is less than 0, roots will be complex and distinct. Actually, roots will be the complex conjugates of each other. Dear students, it was all about the nature of the roots of the quadratic equation. I hope you learned the method of finding the nature of roots of the quadratic equation. See you in next lecture. Thank you.